Hello everyone, welcome to our channel Public Cloud Design Tips and Tricks. In this channel, we generally discuss about public cloud design problem statements and their related solution. Today, we are going to discuss about one of the pillar of Azure well-architected framework is known as Azure Reliability. So, before that, let's try to understand what is our problem statement. The problem statement is the principle to design reliable solutions in Microsoft Azure world. So, to realize this, what Microsoft has provided? Microsoft has provided in well-architected framework, the core principle or core pillar of the well-architected framework is reliability engineering. So, what is reliability? A reliable workload is one that is both resilient and available. When we say resilient, that means the goal of reliability is to bring back your application in running state after a failure. That means if there is a crash in your system or your system is getting down, in that case the capability, the design, the solution with which your application will bring back or it will move back to its original state of running, that is known as reliability engineering. And another is availability. When we talk about availability, that means get your application available whenever you need it. To realize these two concepts, the reliability engineering stands. So let's try to understand a virtual machine scenario. So when a virtual machine, you are running a virtual machine and there is a crash in your disk in the virtual machine, then you can upgrade your virtual machine to premium storage. That means you improved the availability of the virtual machine with one tier up. And that is very specific to particular to that virtual machine. So if you try to understand the concept, the hardware behind the virtual machine, basically nothing but these are all racks inside a availability or data center. So there is a crash in the rack completely. Then in that case, what you can do, the virtual machine is also having another solution known as availability set. That means if one rack is crashing, then the other rack will make your virtual machine up and running. That is known as availability set. But when you are going ahead to the data center, that means your entire data center is getting down or your entire zone is getting down. In that case, every availability zones or every region inside Azure public cloud area, you'll have multiple zones inside a region. That means if one zone is getting down, then other zone will make your application up and running. Okay, that's where your availability zones are coming to picture. But what if a region itself is getting failure? In that case, Azure is also having the regional failure takeover, where you can route your traffic from old region to the new region, and there you can have the solution like recovery service vault, and these are all things. So we will talk about the concept behind PRO and RTO in the or RPO and RTO in the next successive slide. So this is how your application or your infrastructure will become resilient. But at the end, this resiliency has been designed by, or these type of capabilities has been implemented by Microsoft Azure. But when a solution architect is designing the solution based on the NFRs, you can opt which solution is needed for you based on the cost and other impact. Let's go to the responsibility model. Then there are two responsibility model which is coming to picture. One is Microsoft, what Microsoft has to do to get your application resilient, and what Azure customer who is using that platform has to do. So Microsoft is responsible for cloud platform including networking. That means in case of availability zone failover or in case of regional failover, in that type of solution has been taken care by Microsoft Azure. But the customer who is building the application, they also have to write down the code so that in case of or write down the solution in case of your regional failover, then your application should also be capable enough to pick up the state of that particular application from other region or other availability zone. So that's how you have to segregate the responsibility between platform and application. That's what we call shared responsibility model. Now let's try to understand RPO and RTO. As you can see here, one application which is getting crashed in this system, then the exact time to fall back to the initial state where it was running perfectly is known as recovery point object. Note it down. Recovery point object is the point where your application is getting back to its original state or the state where it was running smoothly. Now recovery time object is the time it needs to recover so that it will be up and running, known as RTO. So that is the basic difference between RPO and RTO. And to realize RPO and RTO, also there are few data object which is getting lost or few times that you are losing. So that is the concept. Whenever you are designing a resilient application, you make sure your RPO and RTO are also getting met. Now let's try to understand reliability planning. When we say reliability planning, it has few points. First is define. What is defining? You are going to define availability and recovery targets to meet business requirements. That means you have to define a target, that what exactly your business is looking for, and based on that you have to be very clear what exactly you need to achieve. Second, once you are clear about your requirements, then you have to design the reliability features of your application based on the availability requirement. That means if your availability requirement is lower than the regional failover, then you can handle it in availability set, or you can handle it in the availability zone. But if you have the higher requirement, okay, at any cost you do not need, you want your application to be available highly, in that case you can take care of the regional failover scenario. So this is the case where you understood your requirement and you design the solution. Third, align application and data platforms to meet your reliability requirements. As I said, like, it is not only the platform which has to take care. Again, you also have to make sure your application will be capable enough. Even if your application is getting spinned in another region or another availability zone, then it should be able to cope with the state with which it failed, and also giving the response back to the customer who was looking for it. So you have to make sure you align your application in that state so that you realize the requirement. Then fourth, configure the connection paths to promote the availability. That means you have to make sure whenever your first path is getting down, then the next path should be routed immediately. Fifth, use availability zones and disaster recovery planning where applicable to improve reliability and optimized cost. Be focused here when the statement says optimized cost. When you are using such features like zonal availability zones or regional failover, that time a cost is also coming to picture, like active passive. So all these things you have to make sure the cost aspect is also getting taken care. Otherwise, you have a requirement of 6, but you are implementing a solution of 16 euros. So you have to make sure you will meet what exactly is getting asked by your client or your customer. Then sixth, ensure your application architecture is resilient to failures. As I said, like, your application should also be resilient enough, not only the platform. Know what happens with SLA requirements are not met, and also identify possible failure points. That is the most important point of a solution architecture, is to identify what are all failure scenario that can happen with your application. And once you start thinking about those aspects, then your solution can be much more resilient. Unless you start thinking about all these aspects like failure scenarios, your application cannot be resilient enough. So that is where your identification phase is coming. And the last one is build application that operate in the absence of their dependencies. So in case of any dependency absence, your application should be resilient enough to cope it with the changes. So these are all main point you as a solution architect should definitely think when you are designing or you are planning your reliability engineering with Azure. I have gathered all this information by following these links. If you want to know more about it, I will share this link in the Azure in this video description. If you like the video, then don't forget to subscribe our channel, and we will be coming up with more and more pillars about Azure World Architecture Framework. Thanks a lot.